I'm here with the spare heat shield and truss structure. It is an exact replica of what's flying in space. The top heat shield is 8 feet in diameter and 4.5 inches thick. You can see that the top surface has a white coating that was specially designed for the solar probe to reflect energy. It's a lot like being in a white car on a hot day as opposed to a black car on a hot day. You'd much rather be in the white car. The whole heat shield is sitting on a titanium frame that connected to the spacecraft, and the system keeps Parker's solar probe at a cool 85 degrees as we approach the sun. Now I'm going to show a little demo. Hey, Jim.
Hey, Betsy.
So here we've got a cutout of the heat shield. It's the same thing, 4.5 inches thick, carbon-carbon on either side. Carbon-carbon is a lot like the graphite epoxy you find in your tennis racket or in your golf clubs, but it's just been superheated. The inside is a carbon foam. It's only about 3% dense, which is one of the reasons why it's so lightweight.
Okay.
So let's give this a try.
Okay. This isn't going to hurt, is it?
I don't think so.
Okay.
I'm going to get the front surface glowing red hot. It's not quite as hot as it's going to be at the sun. We can't quite do that. But it's pretty hot. I can certainly, even now, start feeling the heat. Jim's going to be able to touch the backside, though, with his hand.
Ready for me to try?
Yeah, let's do it.
Let's do it. Wow, that's very cool. I don't feel any heat at all coming through.
Nothing?
Nothing.
I certainly feel heat. And it's starting to get bright red on the front side here.
Nothing here.
And that is the heat shield technology that keeps Parker Solar Probe safe at the sun.